Hello everybody. Okay, so what we're going to talk about today is how to determine the domain of a rational function and how to find which real numbers cannot be a part of that domain. And in order to figure out what the domain has to be, and in order to find those numbers, what you first have to realize is that under no uncertain terms can the denominator be zero. So you first have to realize that the denominator cannot be zero. Okay? This is a no-no, right? So in order to first find out what legitimate or what valid numbers we can use, we first have to find out what numbers are going to make this denominator equal zero. Because remember, 4y squared minus 36 cannot under any circumstance be zero. So in order to find out what those numbers are, the first thing that we do is we factor. Now, if this was a trinomial in the numerator, and if this was a trinomial down here, or maybe difference of squares here, or difference of squares there, or some type of binomial that's factorable, or trinomial that's factorable, then we would factor everything to see what cancels out, to see if we can get down to something that's just a little bit more simple. Okay, so for this one, we need to find the numbers that's going to make this zero. So here, we need to find numbers. So we need the real numbers that will make this binomial zero. Okay? And to find those numbers, we need to factor. Okay, so we need to factor. So let's start by factoring this. So the first thing that I notice is that 4 is a factor of 36, so I can pull a 4 out of there. So when I pull a 4 out, I have y squared left, because 4 times y squared will give us 4y squared, and minus 9. 4 times negative 9 is going to give us that negative 36. And remember, this cannot be 0. Okay? So in order to find those numbers, what I'm going to have to do is, again, factor this binomial, and notice it too is also a difference of squares. So I have 4, and our algorithm for factoring a difference of squares is we take the square root of this, that's going to be y, square root of that is going to be 3, y and 3, and one we put a plus, and the other one we put a minus or a negative sign. And let me kind of clean that negative sign up, because it looks like it's kind of like crawling out of that 3 there. So let me clean it up here. Okay, so this whole thing under no uncertain terms cannot be 0. Well, to find out where it cannot be 0, we have to find out where it is 0. Okay, so we need to find out where it's 0. So in order to do that, we set our binomial factors equal to 0. So we've got y plus 3 equals 0, and y minus 3 equals 0. Because once we know those numbers, then we know where it cannot be 0. So for here, for this binomial to be 0, y is going to have to equal negative 3. And for this binomial to be 0, y is going to have to be 3. So in terms of which numbers cannot be used in the domain, those numbers are going to be negative 3 and 3. So what did we just find out? So we know -3 and 3 cannot be part of the domain. Oops, spelled domain wrong. Let me clean that up just a little bit more. Here, it cannot be part of the domain because they make the denominator equal to 0. Okay, so to find out what the legitimate numbers are, let's go get another color and let's make a number line. And on this number line, let's put 0, +1, +2, and +3, and -1, -2, and -3. And out here, let's put -infinity, and out here, let's put +infinity, okay? So we've got our -3 here, we've got our 3. Now let's figure out what our domain can be. What are some legitimate numbers for our domain? In other words, what are the numbers that we can plug in here that's going to be legitimate, that's not going to make the denominator equal to 0? Well, to do that, we've got to use our interval notation. And if you remember our interval notation, when the interval is closed, then A and B are not part of the solution. And when it's open, A and B are part of the solution. Okay, so that's what we need to keep in mind. Well, since we can't use -3, we are just going to do this there. And since we can't use +3, we're going to do this. And then we're going to figure out what the rest of our domain is going to be. Well, we can't use -3, but we can use all of the numbers that are less than -3. So one part of our domain is going to be from -infinity to -3. The other part of our domain is going to be between -3 and +3. So we can use all the numbers between -3 and +3, not including -3 and +3, and we can also use all the numbers from +3 out to +infinity. Okay, and since we've got 3 different intervals here, we can join them together by using our union symbol, right? So the domain for so the domain, oops, went too far, for this particular rational function is going to be from -infinity to -3, and from -3 to +3, and from +3 to +infinity, not including -3, not including +3, okay? So let's kind of move on to a similar type of a problem where you're being asked to do the same, something similar. Let me try to get this up here. I have a little struggle there. Let's look at this one. And let me go ahead and let me move that over here. Come down a little bit more. And let me go ahead and get this down. Sorry about the delay. It's just best laid plans. They don't seem to act right when you want them to, okay? So let me click outside of here. Let's see what we get. Okay, instead of belaboring the point with this, let's just go ahead and let's just work with what we have right here. So for this one, again, the denominator cannot be 0, so we're going to have to factor. So we know that b squared minus 3b minus 40 cannot equal 0. So we need to factor this trinomial to find out at what real numbers this trinomial will be 0. So to factor it, we need two factors that when multiplied will give us negative 40, but when subtracted will give us negative 3. So those two factors are going to be b minus 8 and b plus 5. Because if we take negative 8 times positive 5, then we're going to get negative 40. And if we take negative 8 plus 5, we're going to get negative 3b. So now we set these two binomial factors equal to 0. So b minus 8 equals 0 and b plus 5 equals 0. So here b is going to be equal to 8, because if I plug in 8 for here, 8 minus 8 is going to give me 0. And here b is going to be equal to negative 5. If I plug in negative 5 for b, negative 5 plus 5 is going to be 0. So the two real numbers that cannot be used in this domain will be 8 and negative 5. So b cannot equal negative 5, nor can it equal positive 8. So again, if we were looking at this on the number line, we have 0, we've got 1, 2, 3, 4, negative 1, 2, 3, 4. Yep. Can't count here. And this is going to be our negative 5. Now this is going to be out to negative infinity. And we've got 1, 2, 3, 4, 5, 6, 7, 8 here. And this is going to be out to positive infinity. So let's go ahead and let's try to eke out what they're going to be, what our domain's going to be here. So b cannot be negative 5, can't be positive 8. So our domain for this particular rational function is going to be from negative infinity to negative 5. So negative infinity to negative 5. From negative 5 all the way up through positive 8. So and from negative 5 to positive 8. And from 8, positive 8, all the way out to positive infinity. Okay? So that's what our domain's going to be. But the question actually asks is what two real numbers cannot be part of the domain. And this would be the answer for that one. And for the very first one that we looked at, this would be the answer for that. So I hope this helps some of you, most of you, all of you, and until then, talk to y'all later.